In this video, we focus on the tension between the traditional organization of school knowledge in disciplines and the STEM interdisciplinary skill required by society and labor market, arguing why we decided to explore in the project two kinds of interdisciplinarity that we named curricular and STEM advanced interdisciplinarity. As we stressed in the previous video, disciplines can still play a relevant educational role also in adopting an interdisciplinary approach, but also that interdisciplinarity is a fundamental aspect to consider in order to make the students experience authentic science. Moreover, we will show that, as much as the disciplines are important to scaffold and mediate the interaction in the interdisciplinary context, an interdisciplinary approach can be very useful to deepen the disciplinary identities and become more and more aware of their epistemologies. To reflect on the term discipline is crucial to grasp this step. The term discipline contains the Latin root discere, whose meaning is to learn. Disciplines can be seen as a reorganization of the knowledge and the scope of teaching it. Accordingly, both each discipline and their connections and integrations imply deep reflection on what type of knowledge and what epistemic practices are typical of different kinds of scientific knowledge, ways of reasoning, representing, modeling, arguing, communicating, sharing, producing. But the term discipline involves not only the epistemic dimension of knowledge, in particular if we consider an interaction between people with different backgrounds. As stressed by Dagger and Enduran in 2016 in their family resemblance approach, it should include aims and values of a community, ethical and social issues. On the basis of these reflections, the tension mentioned above is turned into the problem to find an equilibrium, in particular in the teaching and learning of the disciplines, between exploiting the educational potential of disciplines to develop epistemic skills and fostering scientific authenticity. As we will argue, this equilibrium is slightly different if we consider the relationship between already established bodies of knowledge with a solid tradition and new habits of fields of research that have not already a consolidated approach and are not organized in an institutional form. Why did we decide to keep them separated? In curricular topics, educational and teaching traditions led to more or less consolidated didactic narratives, more and more aimed to focus on disciplinary elements. In the tension, discipline-interdisciplinarity, the pole discipline prevailed. Here, the epistemic core of the disciplinary knowledge is the focus. The problematic issue is to avoid the collapse from disciplines to information, activate the epistemic structure, and make the links alive again. In the STEM advanced topics, didactic narratives have to be still invented, and disciplines play the role of defining an experience ground from which the new exploration can start from and protect from insecurity, and accept embracing uncertainty and ambiguity. How can the two types of tension between discipline and interdisciplinarity be made explicit and comparable? We pointed out some criteria and key questions. The STEM advanced interdisciplinarity is present in the modules O2 that consist of modules of advanced emergent STEM topics in the society, such as climate change, artificial intelligence, quantum physics application, quantum computers, or nanotechnologies, and health issues such as the coronavirus pandemic. The relevance and the innovative aspects of O2 concerns the cutting-edge and societally relevant STEM topics that are so far not part of teacher education. The focus on how traditional disciplines' perspectives are embedded in these advanced STEM topics and how the different disciplines contribute to integrate each other. The curricular interdisciplinarity is presented in the modules O3 that consists of modules as example of interdisciplinary issues that address border problems among disciplines and aim to show how each discipline has to play its own epistemological role and not to be treated as a mere instrument by the others. The relevance of the innovative aspect of O3 concern The place and role of epistemological issues in interdisciplinary education as a means for understanding the relationships and the common backgrounds. The interrelation of disciplines in history of science as a means to foster interdisciplinarity. In the O2 modules, the disciplines are not present per se, but appear as a contributing to the question at stake, while in O3 modules, 2 or more disciplines are identified to contribute to address curricular interdisciplinarity topics. In our project, 2 modules focus on advanced, intrinsically interdisciplinary STEM topics that are societally relevant but difficult to include in official curricula: coronavirus evolution and nanotechnologies. The other 2 focus on curricular themes that, although blending, curricular and teaching tend to separate them from the discipline: cryptography and parabola and parabolic motion. List of criteria from the table and example of questions that guide the comparison. The O2 and O3 modules can be compared along this direction. 1. Boundaries and boundary objects. 2. Grade of integration and interaction among disciplines. 3. Identities equilibrium. 4. Institutional conditions and limitations. The guiding questions are: in curricular interdisciplinarity, the identities and the established practice of the disciplines involved are more solid so that the dialogue happens at already existing borders between disciplinary communities, while sometimes elements of the disciplines are more mixed and difficult to separate. Do you find disciplinary boundaries in the topics your module deals with? Are these boundaries different if we move from school institution to others? Why? Which boundary objects have you taken into account to make disciplines interact? As we stressed, sometimes we can see clear boundaries separating disciplinary topics in a common interdisciplinary activity. This is more frequent in the case of curricular interdisciplinarity, while sometimes the metaphor of borders do not fit in the specific case, and this is more frequent in STEM advanced interdisciplinarity. New metaphors can help. For instance, we can imagine to project the new interdisciplinary topic on different disciplinary dimensions, looking for known terminology, methods, aims, and values. What are the grades of integration of the disciplines that characterize O2 and O3? Can you use a particular example in the module to illustrate this integration? The issue of identity is double-pronged. Sometimes we focus on similarities between different subjects belonging to the same group, while sometimes we look for features that can allow us to clearly distinguish ourselves from the others. In your module, which dialectic is established between IPSE, conservation of fauna identity and specificity, and IDEM, complementary contribution of discipline to the same problem? What are the needs that motivate the orientation towards conserving the identities, IPSE, or promoting the search for commonalities and pursuing the development of new identities, IDEM, and strategies that, in the design of the modules, have been used to pursue such goals? The change of institutional content can deeply change the nature of relationship between disciplines, even considering the same topic. Indeed, at school, university, or in the research context, the same elements of knowledge can be organized differently, and the aim and values of the disciplines can vary a lot. Which institution and institutional traditions, discourses have you taken into account in your module design? Which conditions and limitations do these institutions establish concerning the epistemological, linguistic, pedagogical aspects for interdisciplinarity? How these institutions interact or may interact for the elaboration of new knowledge for interdisciplinarity at secondary school level?